Hello and welcome to Talk Nerdy. It's Monday, February 6th, and I'm your host, Cara Santa Maria. Now, as always, I want to remind you guys that Talk Nerdy is and will continue to be 100% free to download for anyone who wants to listen. And I'm able to do that because I have a hybrid model on the podcast. I welcome advertisements from, organizations and businesses that I feel proud to support. And I'm also proud that this is a listener-sponsored podcast. And there's a couple ways that you can sponsor it if you are interested in doing so. The easiest and most direct way is to visit www.patreon.com/talknerdy and pledge your support on an episode-by-episode basis. This week, I want to thank those of you who have pledged your support in the highest tiers, and that includes Mark Hepburn, Phil T-Bear, Timothy Glover, Christian Jeffrey, David Lacer, Jeffrey Perez, Stuart Ogg, The Honorable Husband, Charles Payette, Jafe, Gabriel Felipe Jaramillo Gonzalez, Brian Holden, and of course, Jeffrey Sewell. Thank you all so very much. It's because of you that the show can stay on the air. Now, there are other ways that you can support the podcast, most of which you can learn about by visiting my website, carasantamaria.com. There, not only can you look at past episodes in the archives and also other work that I do, mostly in television and on the web, but you can also pledge your support via PayPal, or you can visit the Talk Nerdy store where I have super cool stuff available like t-shirts, buttons, stickers, some really beautiful hand-tooled leather work, including keychains and bookmarks that say Talk Nerdy, and also hand-thrown beautiful, I think they're stoneware mugs that were fired in a wood fire. So yeah, check it all out. All of it goes to support the show. And thank you again for your continued support. Now, this week, I have a really fascinating guest on. I had never met her before we sat down to do the episode, so it was a great opportunity to get to know her a little better and to learn about her research and some of the cool work that she's done on campus as a PhD candidate in material science, really in the physics department, studying plasmonic metamaterials. So if you're interested to hear what that is all about, stick around because I talk nerdy now with Dagny Fleischman. Well, Dagny, thank you so much for coming on the show today.
Yeah, of course.
Dagny's a fun name. Where does it come from?
The book Atlas Shrugged by Ayn Rand, actually.
There you go. How funny. Oh my God, we were just talking about, and I won't say who, but we were just talking about how I was like super depressed that one of my friends seems to have found Ayn Rand late in life. Were your parents big objectivists?
My dad's favorite book is Atlas Shrugged. Oh. And I get such a gamut of reactions.
I'm sure.
Like everything from people like actively disparaging my parents to me when they first meet me, to also, there was one girl who actually heard my name, took me to the bathroom with her, took off her shirt to show me a tattoo from the book, running all the way down her side.
Wow. So. It's interesting because I think there are incredible books that I think shape public consciousness and that have a lot to offer that are just books, right? And so if you look at it that way, I think, oh, okay. And your dad loves the book and he learned a lot from it. And then there are there's the, aren't they called the objectivists?
Objectivists, yeah.
Yeah, there's the objectivist following that is like off the deep end, ultra libertarian, right? Who is basically like forgot what empathy was somewhere along the way.
Yeah, no, it's interesting. Ayn Rand actually apparently tried to write an empathetic, charitable character into the book Atlas Shrugged, but had such a hard time making it seem genuine, just because I think she apparently had such a hard time seeing that actually being something that
she was a sociopath.
Yeah. Yeah. But
that is my interpretation, I should say. But that's so funny.
Yeah.
Oh, how funny. Did that shape some of your kind of leanings growing up?
So I guess to some extent, I mean, might not come as a shock. My dad is very into sort of marketplace finance and things like that. So, growing up, one of the first things I was taught was instead of be nice and eat good food, it was buy low and sell high. And they'd trot me out to their friends and have 4-year-old me say this. So I think that there was some element of that in my consciousness. But now I'm the person that I guess, sort of argues him back in the other direction, just as like I think most quasi-rebellious children would. You know, you see something really strong from your upbringing and you're like, you either really accept it and drink that Kool-Aid or you flip the other direction. I do see some merit in some of his perspectives,
Sure.
but I'm still going to argue him as far back away from them as I can, mostly for the sake of being an irritating child.
I love that. Did you grow up in California?
No, I grew up just outside Chicago.
Oh, okay. All right. So like more Midwestern. But Chicago's a weird thing, right?
Yeah.
Because it's like an island in the Midwest, I think.
Yeah, I have a heart, like I really like ranch dressing, and I feel like that, and I grew up like listening to a lot of country music, but other than that, I have a hard time really saying that I'm from the Midwest because I went to school out on the East Coast, and it felt a lot more East Coast than the Midwest we would drive through when I'd go on road trips with my family. So.
Yeah, it's like I grew up in Dallas, but like a lot of my family, my cousins and stuff grew up in Austin. And so, yes, it's the South. And yes, there is such a Texas flavor to Austin in terms of like the style and the vibe of Austin. But it's so liberal. It's just so not what people think when they think. It's like, yes, I eat ribs, and yes, I eat chips and queso, but I'm also like such a bleeding heart liberal.
Yeah.
You know, it's not quite what people think of. Dallas is a little different. Dallas is very buy low and sell high. Anyway, so I invited you on the show at the recommendation of Crystal Dilworth, who's been on the show before. She's one of my best friends. I talk about her on the show from time to time. She knows you because you both go to Caltech, or she graduated a couple years ago, so went to Caltech, but she still works there.
Yeah.
So she's around all the time. And she was like, you should get Dagny on the show. She's a material scientist, and I don't think you've had a material scientist. And I was like, you are right. I need to do this. So you're at Caltech right now. You're a PhD candidate?
Yeah.
Cool. Where are you in the process?
Oh, God. I'm starting to see that vague light at the end of the tunnel, and I don't know if I'm scared of it or really excited about it. I'm, I guess, a little bit more than 5 years in now.
Gotcha. So are you done with all your coursework?
Oh, yeah. I've been done with that for years. It's weird to identify. Like, I like candidate because PhD student almost seems weird because I haven't sat in a classroom and taken a class in like 3 years now.
Yeah, yeah. And there is a difference between being a candidate and being a student, right? When you're a student, you're not too candidacy yet. You're not ready to be basically all but dissertation. But as a PhD candidate, that's what you do full time is you work on your research. And it's time consuming.
Just a bit.
Just a bit. Have you do you have a hypothesis? Do you know what you are doing for your dissertation?
I do. I guess I have like a broad framework now that I'm trying to fill in. So we were talking about this a little earlier, but like material science is really broad. I occupy the far more physics side of material science. So I do
because sometimes it's heavy
chemistry.
in like chemistry.
Yeah, it sort of like bridges, in my opinion, between like applied physics and applied chemistry. And I work for someone who's effectively an applied physicist. And I'm interested in color. So how light and matter interact to create color. And how can we control the properties of materials to give us really, really specific control over color?
Ooh.
Yeah.
I feel like I covered an article on Skeptic's Guide like maybe a year ago. Sounds about right, but I have a bad concept of time about like the blackest black material. Do you remember that when that came out?
So I know of some like really highly, there are a couple different ways you can make like a really black material. I don't know that one in particular.
But it's probably just some iteration on the research, right?
Yeah, no. So that's actually some of the stuff like highly absorbing materials that are going to be very, very black. We do that in my lab too, actually. We have some folks who are doing like really crazy stuff with high efficiency absorbers, I think is what they were calling it.
Seems right.
Yeah.
Right. And then also like things with the higher, is it called albedo? Like the more reflective they are?
Yeah. So we don't do as much stuff with that, but there are definitely folks who are looking at that as well.
Yeah, because that makes sense, right? For climate change research and things like
Putting
that.
those coatings on your roofs
Exactly.
and things like that.
Like we put a white, well, it's not really white. It's kind of a light gray. We recently redid the roof. And I think here in Los Angeles, you have to. There are like regulations. I think you legally, based on how grandfathered you in and blah, 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 but I think you legally have to do what they call a cool roof, just to contribute back and not to be a sap on the grid. If you have a dark roof, then you're going to bring heat in LA. In different places, that actually makes more sense to do absorbent roofs if you live in a place that's like covered in snow all the time. So yeah, it's cool how something as simple as like the color of your roof can have like a major effect on things.
Oh yeah, I mean, I'm totally biased, but I think color is such an incredibly interesting thing that people just don't spend that much time thinking about. Because you walk around and you see things and you don't really think about like, why is that metal shiny, or why do these things have the colors that they do, and they're controlled by all these really interesting fundamental properties of materials that a lot of times people don't just bring together.
See, so I'm going to assume that when you came into my office and saw my ridiculous and quickly growing Carnegie collection of dinosaurs. By the way, guys, the Carnegie collection is now done. They will be producing no more. I've talked about my crazy dinosaur collection. They will be producing no more. So I went on a buying spree on Amazon and eBay recently, and there's like 30 or 40 of them.
I think there might be more than that.
Yeah. Just on my desk, in addition to all the ones I own hundreds. Yeah, it's pretty bad. And so Dagny walked in and I was like, let me explain. But I'm going to assume that when you walked in, you weren't thinking, ooh, she's psycho. You were thinking, look at all the interesting color.
Honestly, it's ridiculous, but that's what I notice a lot of the time because I spend so much of my research I'm having a hard time with blue on one of my things now, but I spend a lot of time like thinking about colors and making them and being really impressed by like beautiful colors that we see around and things like that. And, you were talking about them being hand painted. And my first thought is like, oh, those paints have pigments that, we control very specifically to give them their color.
I love that. I went on a date once with a guy who is like, he's a physicist, right? And he does a lot of, well, I don't want to get too specific because you might know who he is. So I went on a date once with a guy who's a physicist who specializes in light. And we went to dinner and then we were like walking just outside. And I was like, at a certain point, I had to be like, seriously, dude, because he would point to every light and be like, so this light works this way. And I was like, wow, it must be all consuming.
It's so geeky, but like I do that, but just in my head.
See,
I try to spare everybody around me.
So when you are on dates, you're not explaining why all of the food is the color that it is.
Not unless prompted, unless I really geek out about something.
I love it though. No, it's actually cool to have like such a specific area of expertise. And of course, color is a lot more complicated than I think a lot of people give it credit for because it has everything to do with wavelengths that are both absorbed and reflected by the sun and everything to do with the physiological processes by which we experience color, right? So it's like a dual thing. There's an actual measurable color, which, it's the age-old philosophical question, like, how do I know that the red that you see is the same red that I see? And it's like, well, red is red. Like, that is true.
You may see it mathematically.
Exactly. Yeah. You may see it slightly differently, but it is, defined on the electromagnetic spectrum, invisible light. So so since you're on the physics side, which I guess does make more sense with color, right? What is your specific focus in your lab?
Yeah. So I guess I can bounce off the application and bring it back to the science. So what we're interested in making are, they're called hyperspectral color filters. Right now, and we want to integrate them into the types of cameras that are in our cell phones, which are CMOS image sensors, these like tiny, awesome, powerful little cameras that we have. Right now, those sensors filter 3 colors, red, green, and blue. And they can, the camera can then take those colors and triangulate it to a color value. And so at every pixel in an image you take, you have this triangulated color value. What I want to do by turning it hyperspectral is instead of just looking at 3 colors, look at between like 50 and 100. And what you could do there is instead of triangulating to a color value, you can build up an entire optical spectrum. So when you take a picture with your camera, you could say, okay, that point in space, I can see how that interacts with the entire visible spectrum. The reason why that's really useful is since all these different materials, as you were saying, interact with light differently, we can take a picture with that camera, know the spectrum, and then hook that into a database and be like, oh, this material has that spectrum. So using your cell phone, you could do pixel by pixel material identification. So whatever you see around you, you could take a picture of it and you can know what it was. Or the application I really like is cancer tissues have a really different spectral signature than healthy tissues. So you could do things like take a picture of a funny looking mole on your arm, be like, oh, is that cancer? Let me pull out my cell phone and it can tell me.
Oh, that's
There's a lot of really neat stuff you can do.
That's really cool. Yeah, I think we don't think about the fact that the spectral or the color, signature of something could actually give you core information about its properties. Like something could be wrong because it absorbs more light or reflects more light. it's very similar to the fact that tumors, at least some tumors, have molecular markers on them, right? They're a very specific type of tissue. And so we've learned to be able to target them, and instead of just like murdering all of the cells using chemotherapy, we can use more specialized chemo because it's like, oh, we'll just go after the cells that have this one antibody on them or this one molecular marker. I love that. Like, we're getting more and more specific with medicine. But this is also really interesting, I think, just on a basic science level. Like, even if we didn't have any real applications, okay, this might be a naive question, but in these spectral, are you calling them not lenses, but filters?
So they're just color filters.
Filters,
the light passes through it. The ones I'm designing are transmission filters. So all of the light, that's shining somewhere, that's bouncing off of something, will hit the filter, and only very, very, very specific colors will be allowed to pass through.
Gotcha. Does it look? If it's going to be in a camera, would it look the same to your eye if the filter's in between you and the object?
So you actually can't even see these filters by eye. So that's like the first part. It's because these CMOS image sensors are so small, and that's what makes these filters distinct from other really narrow bandpass filters.
Yeah.
I'm trying to make filters with a footprint that is about 1 micron squared.
Okay.
So they're way below the resolution of our eyes.
And if they only filter specific wavelengths, do they block certain things from getting to your eye?
Yeah. So if our eye is the pixel that or the color filter, then so it's only going to let through very, very narrow bandwidths of light. So like, piecing apart like red, deep red, red, only like one of the very particular reds. I need more words for colors.
I was going to say, that must get really complicated when are you always like talking about chartreuse and like,
I do. In my examples, usually I actually go to the greens and use chartreuse as the example because it's like lime peel, chartreuse, forest green. I don't know why I jumped to red today. But usually when I'm talking about it, thankfully I have numbers as a proxy. But
yeah, that's true. That's true.
In cases like this, I'm like, you're
like,
mac and cheese
blood.
Orange.
Yeah,
I need to like
it's
study
just, like,
my Crayola colors a little bit better.
Mac and cheese orange. That's so gross, but I love it. That's awesome. And so, okay, do these filters work the same? Or I should say, especially if you're talking about more of an automatic kind of data processing. So you take a snapshot of life, a still life, something, and then the filters filter out very specific wavelengths, and they could help you basically like mass spec. They can help you identify what you're looking at the same way that we can use mass spec for very small chemicals, right? You can, if you're afraid somebody got poisoned, you can take a sample and you can run it through the spectrometer, and you can see if they've got the same wavelength, quote unquote, of what's a poison?
Cyanide.
Of cyanide, yeah. And they're in trace evidence of cyanide in them. And you just look at, anybody who watches Forensic Files knows what I'm talking about. And obviously, we have a friend, Holly Bender. Re-listen to the Holly Bender episode. She works at JPL. She works on, we call her the Mistress of Space Rainbows.
Oh, I love it.
Yes, because she works on spectrometers. She's actually an optics engineer. And so she makes spectrometers for spacecraft. And some of it, I think, was like near Earth stuff for like climate change and weather, not so much weather, but like the health of trees based on like the gases that they put off. And you can use mass spec for that. Maybe it's not mass spec, but I can never say it. Is it spectroscopy? Yeah. But it's a spectrometer that does spectroscopy.
Yes.
It's not a spectroscope.
Spectroscopy. No, a spectrometer.
Thank you.
So I think mass spec is just one type of spectroscopy is the umbrella.
Yes. Okay. There you go. Maybe I shouldn't be saying mass spec. I'm so used to mass spec in the like biology lab, but I think what she's doing is probably just a different type of spectroscopy. So that was a weird tangent, but just like similar to that, I've always wondered, and it kind of comes from some of the study that I've done of digital character building in movie making, because a lot of that has to do with light. It's about capturing somebody's likeness with all these different filters and then putting that data into the computer and then rendering out like a full character map with all these different reflectance patterns and things like that. And then you can actually manipulate it and use that as a digital character. It's how they did Benjamin Button. It's how they brought what was his name? a couple of the actors that have like passed away before a movie was finished. It's how they bring them back to life. It's and it's how they do character creatures that makeup would be too hard, like, you know, Maleficent or that's like a really old reference, but that is what was happening when I was doing the study. Or what's a big one? Oh my God, see, this is what happens when I podcast in the morning. Avatar. A lot of that is digital, like, because it's just too hard to do that with pure CG. Anyway, one of the biggest frustrations that I found from the researchers who do that kind of work is that different light conditions completely change color, right?
Yeah.
Like but color is constant, but in low light, we perceive it completely differently than in bright light. You know, obviously, because we switch over from rods to cones. Does a filter or a sensor perceive color the same in low light as it does? Can it can see the constancy?
So it's, you know, there's a certain, I don't want to speak for all filters just because I can only speak for the subset that I work with. But at least the ones that I work with, the mechanism by which they filter won't change in low light versus high light conditions. It's completely the same.
So even if to your naked eye, red actually almost looks black. My dog's trying to come up and say hi. Come on. He gets scared sometimes if he's going to hit his head on the table. Oh. I know. It's so sweet.
So
he's being our sweet little mascot today. He's sitting in my lap. I wish you guys could see Killer. I'll post some more pictures on social media. So if you're looking at red in low light, say you're in a Italian restaurant and it's really, really dark, right? And you have a plate of spaghetti in front of you. In really low light, it's like you know that it's red because you have developed the ability to kind of make inferences about color, even though... I guess here, maybe this is my own biological expertise. I don't remember much, but I do remember loving all of my vision units in neuroscience. It was my favorite. So you've got the rods, you've got the cones. During the day, you predominantly, or I guess in the fovea, which is the most focal point of your eye where you have all of these cells, you're predominantly using your cones, and your cones are really good at color perception and like high resolution. At night, you're predominantly using your rods. And rods are really good for motion, but they're a little bit grainier, which is why late at night, your vision looks like fuzz on TV. You know, it's fuzzy. And so you're in a really, really dark restaurant. You know that your spaghetti is red. Like, you know it's not green, but it doesn't really look red. You can kind of make that inference, you know, based on the fact that it's way darker, but it still has like redism to it. So a filter can do the same thing.
Yeah, so because it's that spaghetti sauce, the light conditions around it aren't changing unless it's, you know, different types of light unless there is no red that's incident on it.
Gotcha.
But the lighting conditions won't change the fundamental nature of that spaghetti sauce for like what wavelengths it absorbs, what wavelengths it scatters, what wavelengths it reflects. And so these filters are very similar to that.
So you might be blowing people's minds right now by telling them that like red is red.
Red is red.
Yeah, like regardless of how you perceive it. And the truth of the matter is our biology is pretty consistent. We have good reason to think that the way you perceive red is the way I perceive red, unless you're red-green colorblind.
So I read a really interesting study. I'm sure someone's going to tell me I'm wrong about something here, but
it's fine.
What I read about was apparently, I want to say it was in Korean, there's a very specific word for between yellow and green, kind of chartreusey.
Yeah.
And someone did a study where they would put panels of like very similar, or the same, or slightly off panels of green, and yellow. And people who speak Korean and use that word a lot had a much easier time separating which was when the panels were the same and when the panels were different than people who didn't know that word, which seemed to imply that actually there is some change in perception.
Yeah, especially based on language, which is so Arrival. Right? That makes me so happy. Have you seen Arrival yet?
No, I haven't.
Oh my God, you have to see that movie because like that's like a core feature. I'm not going to spoil it for anybody. But this idea that sort of linguistics and the way that we interact using language can potentially, it's a hypothesis, I think, in linguistic studies, but actually does change the way that we think.
Just so cool.
You know, yeah, it's like a foundational necessity for thought. And so if you're raised in a culture that has a more like pictorial language or versus a graphical written language, or if, you know, obviously you speak a language where you have all these different words for very specific things, then you're better at parsing out the differences between them, which is kind of interesting.
So neat.
And also probably in different parts of the world, you see things differently, you know? I mean, I don't know if it's a myth or not that like Inuit people have like a lot of words for snow. I think they do. Or like obviously in Hawaii, people have a lot of different words for ocean conditions and different ways that you perceive the sea. But when you're surrounded by blue ocean, which is sometimes green, or when you're surrounded by white snow, you must be able to detect differences and like when it's dirtier or darker or yellower or whatever. Whereas I'm like, I raised in Texas and then live in LA. When I see snow, I'm like, what is this white devil? So it is cool that
I think it's so neat.
Okay, fine. Maybe the way you see red isn't the way I see red. That's awesome. Yet the way science sees red is consistent.
Yes, it is a wavelength definition that, you know, we have detectors that can very specifically ping your computer with, yes, red is here, no, red is not here.
Don't you love that about science?
It's so cool.
It's so comforting, isn't it? It like brings order to a chaotic world.
Yes.
When there's consistency and when the...
If only my samples were that consistent all the time. Let's not get too far ahead of ourselves.
So when you talk about your samples, are your samples real life objects?
Yeah. So so within like the whole suite of like, designing these filters, integrating them into camera chips, and then creating this database and having the computer know exactly how to address it. My area that I work in is I do the design of the filters. So thinking about like how we can utilize physics to be able to design the sets of circumstances that we want, all the way through building them to test prototypes that we measure. So that's actually when I mentioned earlier that I have calculations running right now. I'm actually running a suite of optimizations to like calculate hopefully the next batch of filters that I'm making.
Yeah, she's very efficient. She couldn't just walk away from the lab. She had to make sure the lab was still working while she was here for the podcast, which I appreciate.
On the off chance my advisor happens to be listening, I'm still working, I promise. But yeah, so the field that I'm in within optics, it's called plasmonics. They're these oscillations of electrons that can interact with light on the surfaces of some metals.
Okay.
And so the color filters that I'm making right now, my first version were just layers of silver and glass. Okay. And by very specifically tuning the thicknesses of the layers, making slits that are actually, it's cool. The slits are actually smaller than the light that's trying to pass it through. So these color filters, they seem like pretty much just blocks of material, either blocks of silver, I shouldn't say blocks, they're like 70 nanometers thick. Yeah. Very, very thin blocks.
Very fragile.
Seriously. Very, very thin, delicate layers of silver and glass. And what I do is I put holes or slits that are usually between 50 and 80 nanometers. And just for the sake of comparison, the light that I'm filtering through is like 400 to like 750 nanometers. So an order of magnitude larger. So the idea is like these color filters work where you have a really, really tiny hole. Think like trying to throw a tennis ball through an eye of a needle, but only particular color tennis balls can make it through the eye of that needle.
Gotcha. So it's big enough for a photon to pass through?
No, it's too
not
small.
So how does the color get through if the photon can't get through?
That's where the plasmons come in.
Okay.
So plasmons, you can have light generate these plasmons, and the plasmons will actually be smaller than the light was, have the same amount of energy, but the properties are slightly different. So I design these filters so only very particular plasmons can be generated that correspond to whatever type of light I want to filter through.
I get it. It actually reminds me of something you sometimes do in biology. I always have to make biology connections because that's where my head is at, where like you might be looking for a fungal species and you'll use these certain filters. Like filters are big in a lot of different aspects of science. They're like little sieves, basically. You'll use these filters, micron length filters, and they can't the fungal species can't go through, but the spores that it produces can. Yeah. And then you can actually identify the fungal species based on the spores.
That's a really good analogy. Yeah, I might use that one next time I try to talk about it.
And so you're not directly measuring the light, but you're measuring a companion to the light that always tells you what that was.
So I guess the only difference would be the way these filters work is so I guess it's kind of like if your fungal spore, the fungus would make these spores, they go through the filter, and then the fungus generates from the spores outside the filter again.
Oh,
yeah,
that's
so
cool. Okay.
we take light in, turn it into plasmons. The very particular wavelength of plasmon can go through the filter, and then it's out scattered into light again.
Oh, that's neat.
Yeah, but now you only have the very, very particular color of light that's hitting the photodiode that's under it that says, oh, light is here. So if it knows what color filter is above it, whenever that ping happens, it's like, oh, we know that it must be light of this particular wavelength.
Yeah, so anybody who maybe has never been in a science lab but who is in the kitchen, you might use cheesecloth, you might use, I'm trying to think of other filters, other grates, other sieves in order to get one thing out of the sauce that you're making.
Yeah.
It's as if you could filter out all of your blueberries from your sauce, and then you can actually make them like spontaneously recreate on the other side of the filter.
Science is really cool.
Amazing. That is really cool. Oh, and it also sounds really tedious.
Yeah, no, I mean, the saving grace for like making these things, I use a lot of like really big, really fancy, really expensive tools and equipment. So like, to make these things, I mean, if you're making things that are smaller than light, which is what these holes are, you then have to start playing games with like all sorts of other forms of tools. How do you make a 50 nanometer hole?
Yeah, I was going to ask, like when, in the biolab, when you're using those kinds of filters, generally speaking, you can just purchase them, right? Because they're measured at certain things. And if you're trying to filter things like DNA that are very small, you might use a gel that has different size holes in it. When we would make glass plates, which were on the microscopic scale, not the nanoscopic scale, you could actually use a microscope. If you're doing something that's multiple microns across, you can use a laser, you can use whatever underneath the microscope, and you can actually physically like engrave or do dissection or whatever under microscope. That's what micro really refers to. But at nano, we don't have nanoscopes.
No.
Right? Like you can't manipulate something with your hands and your eyes at the nanoscale. So you're relying on other materials, other tools to do things like etch or cut or break for
or
you.
like draw all the designs. I think it's amazing. No, we have this one tool in our labs. It's called electron beam lithography. So you collimate a beam of electrons, and electrons, particles could be particles or waves in quantum world, right?
Yeah.
And so the wavelength of electrons at the energies we use them is much smaller than the wavelength of light.
Gotcha.
Which means we now can do a lot of the things that you were doing with light, but we use a collimated beam of electrons. And it's a very sensitive piece of equipment. We have it on all these like really impressive stabilization, like tables
floating
and
tables
things.
and stuff. Yeah.
But like the floating table is like in the underground, but also like on the bedrock. But it's so sensitive that like I work here in LA too. When the Japanese earthquake hit, our tools paused because it detected the shockwave from
That's
it.
amazing.
Across the Pacific. It's amazing how we can make these things that are like that precise.
So do you tell all your friends, you're like, guys, there was an earthquake today?
No,
like, I know
my friend was on the tool when it happened. He's like, buddy, something happened. And then
amazing.
Lo and behold, we're like, yeah, there was a huge, destructive, catastrophic earthquake.
Yeah, and it's like, it's either detecting that or like your dumb lab mate like falling over and kicking the table.
Yeah. We're putting in another tool in that room right now. So and the workers come in from like 8 to 6-ish. So now everyone's just working from 6 to 8.
Oh, how funny.
Because, when people are working in that room, you just can't do anything.
Well, yeah. And I remember Holly saying that a big part of her day and her life is just calibrating things. Like that's just what she does all day.
Yeah. No, measurement is my least favorite part of this process, calibrating like the optics setup to like make sure that the thing you think you're measuring is what you are actually measuring.
And that you're not getting a measurement that's like an order of magnitude different, because when things are that small, a little mistake has a really big consequence, and you really have to know that there's validity, that you're, like you said, that you're measuring what you think you're measuring. That's awesome. It's sometimes just the necessity of doing the research, or I should say the necessary tools, the necessary protocols to do the research that we do, stopping and taking, I don't know, like stopping and really looking at it makes me sometimes more amazed than the research that comes out of it.
Oh,
like we don't stop and do that enough.
No, there's a tool I was pretty recently trained on. It's a transmission electron microscope, TEM.
Yeah,
Where
yeah.
you just sit and you look at atoms. Like you make and that's tedious, making the TEM samples, like things that are so thin that electrons can propagate through it properly.
Oh, that's even smaller. Yeah, that's crazy.
So you make the really small TEM samples, but then you put it in, and if everything works out, you just see like these gorgeous rows of atoms.
Do you remember, I think it was IBM who did the movie A Boy and Its Atom?
Yeah.
And they actually were able to manipulate individual atoms to do a little stop motion movie. And it was like a stick figure, and then he had one atom, which was like a ball or a dog they tried to make. And then he like jumps on a trampoline. It's
we
incredible.
can do that. We as humans can do that. Whenever I get like kind of, sad at the state of like things going on in the world, I'll like sit back and I'll pause and I'll think about, curiosity, in those 7 minutes being able to work autonomously, or the fact that I can, if I wanted to this afternoon, go and just look at some atoms, like with my eyes. It's unbelievable.
And it kind of sometimes brings you perspective. Not only does it bring you perspective of like, oh yeah, we are doing great things, but it also kind of reminds you of like the anti-science people, the people who don't kind of understand the scientific method, don't believe in it, don't trust it, have gone astray for a number of various reasons. In the grand scheme of things, it doesn't really matter because science is doing amazing things regardless of whether these people are supporting it or are interested in it or actually believe in it. You know what I mean?
No, it's true, but it's one of those things where I find that because science are doing all these amazing things, it's actually not terribly difficult to get people to re-engage with science.
Yeah, especially if you can really illustrate it in a way that's meaningful and a way that speaks to them.
Yeah, and it's a thing that I wish like one of my biggest pet peeves is that scientists, we're not trained, we're hardly trained to communicate to our peers.
Yeah.
If anyone's been to an academic conference, I'm sure they can attest to this. But like, we're not trained to talk to our peers, let alone people who are scientists outside our disciplines, let alone the general public who, we assume should think that, the work that we're doing is really interesting and exciting, but has no real reason to. Like when I look at like the computer that you're using, I look at it and I see, the research that went into the transistors and into the display and into the capacitive keys and all of these things. And for me, it's just this amazing testament to science. But people who aren't trained in science don't necessarily think that way because they haven't been told about all of there's nanometer sized gates in the transistors, tens of nanometer sized gates in the transistors in your processor. Like that's amazing. And we could just carry this stuff around. Oh, no big deal. I just bought a new laptop and it was like really not that expensive for nanoscale stuff.
And we kind of
unbelievable.
And not only that, we're so quick to adapt to something new and be like, oh, it's not working. Like, oh, why? Like what? Or like I just bought a new laptop. I bought the new MacBook Pro and it was expensive. It was like $3,000, which is insane. I mean, that's like a mortgage payment.
Yeah.
But at the same time, and I saved up a long time for it, but at the same time, like, it should be expensive. Like, it's got incredible technology in it. And it's like an early adapter of that incredible technology.
Yeah,
I want to be on the cutting edge and I want to be able to use the newest thing. And that comes with a price. And I hope, I try to appreciate that. But I also understand what it means to be a consumer who's not completely aware of these things. And you're right. Not only do scientists not do a good enough job of communicating those things, even the scientific kind of like what I do, the science communication sort of industry field, whatever you want to call it, we're struggling sometimes to do that. But I say all the time, this is why I do what I do for a living. I would love for my job to be rendered obsolete. I'd love to not have to be a middleman, to not have to read the research and try to translate it, or to have individual science. Well, I don't want to never be able to have it. That's fun for me. So I want to be able to do that. But the core need of having individual scientists on and having a conversation with them so that we can pull that data out. Of course, but this is why I love grad students. I always have grad students on my show over actual principal investigators because the grad students are really good at talking about what they do. You notice there is an age difference there. And I think it's because of social media, and it's because of being a digital native and just being aware of how important it actually is to be able to communicate those things. You just didn't have that when you're, 70.
No, this is true.
Yeah.
But I wish that we had like some sort of campaign where you could just like have a bunch of stickers and like put them on laptops and be like, this laptop brought to you by quantum mechanical time, like, and like our like solid state memory, like flash memory. That's the reason why that works is quantum mechanics. And like you take something that sounds super esoteric and it's like, nope, it's in the palm of your hand and functioning well.
Yeah.
Like
I think Louis C.K. did a really great stand-up. I hate like mentioning stand-ups and then I can't do the jokes nearly as well as they do, but definitely look up Louis C.K. stand-up. I think he did it on like The Late Show. And it was a joke that I think he was practicing on The Late Show. And then it later made it into one of his stand-up routines where he's talking about being on a plane and Wi-Fi was first available on the plane. And everybody's like, this is amazing. And then like 5 minutes later, it broke. And they were like, we won't be able to have it on the rest of the plane. And how people were like immediately like, oh, that's bullshit. And he's like, how quickly we are angry about something we didn't know existed 5 minutes ago. And then he's like, literally, or like when people are on their cell phones or on, their computers and it takes a little while for that. And he's like, you realize that's going to space. Like it's going to space and then coming back to you.
Yeah.
Like what the fuck? Like be patient.
And I mean, I fell prey to this too. Absolutely. Yeah. And so it's like if like someone who's like hyper conscious of these things or tries to be can't be mindful of it. Like how do we expect everybody else?
Exactly. Yeah, because how do you know at all? Like how do you know? And I think that you're right. There's this black box mentality about technology, which is like, oh, the experts did that. And oh, the geeks, the engineers. Like they don't even really, or we, I think as a culture, don't even really always think of it as science. We think of it as engineering and somehow that's separate from science. So somehow that's just people in a lab building things. And it's like, no, it's kind of two sides of the same coin. We have to do the science to know how to do the engineering. And the engineers have to be pretty aware of the science that got them to that place. And the scientists have to be aware of how the engineers are going to use their science. Like this is the model at places like NASA, right? There's like some scientists, there are many more engineers, and they work so closely together because without both sides of that equation, you can't build a spaceship.
Yeah.
And it's complicated shit.
Oh, seriously. But it's amazing that we get it to work and we get it to work as well as we do. Like I'm constantly I'm sure you've heard about the guy who went about like trying to figure out like if a person could make, I think it was just like a pencil. Like, is there anyone on this planet who can like fell the lumber and refine the ore and all of these things? And it came down to like, no one can make a pencil, let alone, I think someone actually did try to make a toaster. Like I saw he was like, I'm going to take like 8 months or something and I'm going to make a toaster. And I think it vaguely worked, but everything, like he was going to make the plastic, he was going to like do everything.
And yet that's something we can buy literally for $10 at Target. When the first thing goes wrong with your toaster, instead of taking it someplace to get it fixed, you're like, I'm just going to chuck it because it's like only $10 to go buy a new one. And I think if we had more respect for the science that goes into these things, we would also have more respect for the actual physical object, which I think in many ways loops back to the episode that I did just a few weeks ago with Joe Ruxton about a plastic ocean and about how we just really didn't have the foresight when we first came up with plastics, which is a really big achievement of material science. Plastics opened up so many doors, yet it also has this very nefarious end to it. And she was, I think, so good when I was interviewing her to say, like, plastic's not the enemy. Like, we need plastic. And plastic has been life-changing with, medical technology. There's so many things that we couldn't do without plastics. But then there are other things that maybe we shouldn't have chosen plastic for. And we definitely didn't think about the outcome of the materials as we were starting to integrate the materials on a big scale. And I do think that having more mindfulness and having more respect, and awe for the science that goes into producing these materials probably influences individuals to think more about the outcome of using these materials as well.
Absolutely.
Because, a lot of interesting materials are incredibly safe and biodegradable or easily recyclable. And a lot of interesting materials are highly, highly toxic. And we have to understand the differences between those things and how we're using them. Rare earth metals, for example, there's only so many of them,
They're
right?
rare.
Yeah, they're rare. So we have to be careful with how we use them. It sounds like you mostly work with glass.
Yeah, so that was actually a conscious choice for like limiting the parameter space, because if the eventual goal is to, give this technology to the engineers to integrate it, if I made these out of palladium and magnesium fluoride or whatever, like, that there's no way to to mass produce them. Like maybe it would be possible, but it would be prohibitively expensive.
It'd be so expensive, and it might be somewhat dangerous, depending on what those elements are that you use inside of them.
And so finding, one of the constraints that we placed on the project was how can we achieve this optical phenomenon using a base of materials that would allow for CMOS integration. Which,
like that.
As a designer, I really liked, because anything to help limit the parameter space helped make the problem a little bit easier in terms of all the different directions to look at it in.
So I love that material scientists, especially who do what you do, or similar things to what you do, are designers, that there is a very kind of creative and artistic approach to that. And I want to talk about that, I think, right after we take a quick break to thank the sponsors of today's episode. All right, we are back with Dagny Fleischman, and we were just talking before the break about how you're a designer. As a material scientist, a lot of what you do is you design these materials, which is, we often think of designers as like, fashion designers or furniture designers or interior designers as much more artistic, much less scientific, quote unquote. I'm doing huge air quotes because I know there's a lot of crossover, but I think a lot of people don't think about how much crossover there is in what we think of as creative endeavors and science, which is really creative.
I agree. I have a whole bunch of thoughts about this, actually. I mean, the first just being that the fundamental idea, people often ask me what material science is. And and it spans a whole range of different types of materials and types of questions that we're looking at. But the fundamental idea is first, looking at trying to understand how materials work. Why do they have the properties that they do? And the reason why we care about those questions so deeply is for this design element. You can't design a material to do exactly what you want it to do until you understand how those types of properties arise in materials. And so there's this really cool understanding that leads towards what really does feel like a very much an organic design process that is facilitated by, specific rules and laws, very, very much akin to the types of design that you do in other disciplines, where you still are looking at different rules and laws and working within certain available parameters. It's interesting that you bring this up, though, just because that was actually the thing that got me into material science was this like very creative, artistic thought process. I was actually, you don't know this, I was a really intense fine arts student. For the vast majority of my life, I was in like a really, really intense fine arts program where I had first period art, second period art, third period physics, and fourth period lunch, which was art. And so it was really annoying to my physics teacher who, because, of course, if you're in the middle, if you're going to be working on something for 4+ hours, like taking this, or if you have 4+ hours, 3 of them are devoted to one thing, and then you have to take this weird break in the middle.
Yeah.
I was that asshole high school kid that would just like bring my art with me to my physics class and, just keep on working on whatever I was doing. So actually, in an effort to engage me with physics and with science, this teacher first asked me, do you ever wonder why your paints and pigments have the colors that they do? And explained that was physics and material science. And then the other part of it was this very creative design part, which is really, once you understand the basics of any of these disciplines, it is an extremely creative process. And I feel like I can say this as someone who spent so much time and still spends a lot of time doing more artistic endeavors. The parts of my brain that I use and the ways that I think about things, very similar between the two. You just have different rules that you're operating with.
Absolutely. I mean, guys, we need to get over the myth that like there's a right brain and a left brain, and there's a creative brain and an analytical brain, and all of these things are happening in all of these like integrative cortices, right? And yes, there are parts of your brain that are better for linguistic processing, and there are parts of your brain that are better for visual processing and things like that. But creativity happens all over your brain. And science, by its very nature, is a creative endeavor because basically all science is using the scientific method, and all using the scientific method is problem solving. It's going, I want to understand some sort of rule or law or understanding of the natural world, so I'm going to interrogate it, I'm going to investigate it, and nothing's going to work and everything's going to break, and I'm going to have to figure out how to fix it all, and then eventually I will have some semblance of a preliminary answer to share with people.
Ideally.
Yes, and that is creative. You have to be creative to figure it out. And a lot of times the coolest stuff that comes out of science is not so much the answers to the questions, because they just beget more answers, but the technology and the tools that scientists, who are not often materials designers, right? They are often don't have any expertise in that, have to just build or fashion together or stick together with gum and glue in order to actually answer their question. Because those tools don't exist on the market.
Yeah, no, and that's actually something that I think is just so neat, just walking around our lab spaces. And is you walk past, we have room after room after room at these like big machines that are covered in aluminum foil and have like things stuck on and other things that people are taking off. And it's a very like, this doesn't exist, but I need to do this thing. How can I make it happen? Kind of thought process that obviously is not only huge in science, but I find to be widely applicable elsewhere too, which I appreciate, being formally trained in the how do I hack this until I can make it work.
Yes, and every lab is like that. I remember the lab I worked in when I was getting my master's, and it was two sides of a lab, right? Because it was a neuroscience lab, but we did work on microelectrode arrays that we produced in-house. And so we had to do cell culture, take the tissue out of the fetal mice, grow individual nerve cell networks, and then we grew them on these plates that have all these microscopic electrodes so we can look at activity across multiple electrodes. So you've got the culture room, which is actually the cleanest, and that was my domain. And then you had the like lithography room where you would actually make the plates with the indium tenoxide, because it's too small for wires, so you have to do this photolithography. And then we had the electrophys room where you take all the measurements, and it was so jimmied. Like it's like a scaffolding of wires in the ceiling. And what was the rule? If anything broke, follow the spaghetti. I don't know. Like just follow the spaghetti until you figure out which wire is not working. And then like, these hand-built Faraday cages that are all ghetto, like surrounding everything. And everything's got like paper jammed into it and like paper clips stuck to it to like make sure you're making good connections with the metal to metal. And that's how labs are. When you see a lab in a TV documentary, I can almost assure you, because I've worked on both sides of this, I can almost assure you that the producers came in and, quote, set the lab. They moved all the glassware to the front. They put funny colored liquids in them, which never happens. And they like threw weird lights underneath them to make it look a certain way. Labs don't look like that. Yeah, labs are always really ghetto.
And it's funny too, because like a lot of institutes and organizations will like advertise with, it's always blue liquid.
Always blue liquid.
In all of the different glassware, you have like green lights and blue liquid on everything all of the time. And it's hilarious because anyone who's like I've spent more time than I probably should have in science labs. Nothing like it. And I almost think it's a shame, because I think part of the beauty of a lot of these spaces is all of the jerry-rigged, hacked,
absolutely,
like ridiculous, like I'm trying to think of like one of the crazier devices in our labs, but like you have all these like ridiculous mirrors in like odd places with like Post-it notes everywhere. Do not touch this. Yes. Do not touch this under penalty of death. If you want to live to see tomorrow, do not touch my optics setup. Everywhere.
And in our lab, we had these pieces of tape. My professor, Dr. Gross, who we love dearly, but he had a tendency to just come in and fuck up your experiments. So we had these pieces of tape in front of our recording like pods, where we'd tape our pods down and be like, Dr. Gross, do not cross this line. And then, of course, you always had the refrigerator that was like for food. For, botulinum toxin, like do not mix. And yeah, the Post-it note is or what is it, lab tape. It's like you have the stickies of all the different colored lab tapes that you use to label. That's so funny. But yeah, that's how all labs are. They're all kind of jerry-rigged. And it's funny that you mentioned the photos of like the blue liquid or whatever. It's stock photography, right? Like people produce stock photography. I think I posted something on Twitter recently. I probably won't be able to find it quickly, but I'm going to give it a quick go. And I used stock photography because it was the picture that came with the article. And my internet is so slow right now. And it's just like, I don't know, some schmo looking at a test tube full of, like you said, like blue liquid or something. And somebody commented on it because it had nothing to do with the article whatsoever. And someone commented on it something like, is this liquid blue? It looks blue to me, which is like so perfect because, yeah, that is what stock photography is. It's always people with pH buffers looking at them as if they're going to discover something inside of a pH buffer. It's like, no, that's not what it's for. Oh, I found it. It's not blue in this one. It's orange. It's like a guy in safety goggles. I have to show you. I know other people can't see it, but it's a guy in safety goggles just looking at and then
and like safety goggles, but like not a like because that looks like a button.
Yes. A what?
So not in a lab coat or anything.
No, yeah, he's not in a lab coat. He's in a white button-down shirt. And then he's wearing safety goggles. He has a rack of test tubes. And
is he wearing gloves or not? That was another.
No, he's not wearing gloves at all.
But
safety goggles, no
eyes,
gloves.
His eyes are
His
safe.
eyes are fine, but he's holding the test tube with his hand. And he looks really like he's really concerned. And it's a series of 4 images. And the person who wrote back is at Sonicase on Twitter. Thank you so much because this cracked me up. Law stock photos. Quote, yes, colors. Here's the orange one. It looks orange. Diane, write that down.
Yes.
It's like so amazing. So, yes. And of course, it's for an article about reproducibility in cancer research. An effort to reproduce findings of 5 prominent cancer studies has produced a mixed bag of results.
They were able to reproduce the orange.
I know, right? Which is funny because it's kind of what you were.
I know. So you can't give colors too much help because
exactly.
I'm sitting here wondering, like, I wonder exactly how they made that orange and that blue.
That's awesome. So anyway, I wouldn't say enough talk about work because I could talk about work for ages, but I do want to talk about some of the cool stuff that you've done on campus because when Crystal first sent me an email to introduce you, she was like, I can't say enough nice things about Dagny, and she does really cool material science, but she's also been a real advocate for kind of change and understanding on campus, especially when it comes to student sort of health, I think is maybe a good way to put it. And so I asked you a little bit off air, but I want to kind of repeat a little bit of what we talked about. I want to see what she said. Here, if I had to explain the sheer force of Dagny's awesomeness, I wouldn't do her justice. I love that. Blah, 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 about this, plasmonic metamaterials. She's also interested in science communication. Oh, she's active in our campus diversity program. So that's how she put it. Mm-hmm. So I want to know what exactly you kind of have done around Caltech campus as, by the way, somebody, I'm not going to say your age on air because that's very rude, but somebody who's much younger than I am and who is very accomplished. What are the things that motivated you to kind of speak up and get involved on campus?
Yeah, so I have very interested generally in like the administrative runnings of the institutes that I'm at. And so I've spent time in various meetings with administrators and faculty members at Caltech. And one thing that really struck me is we have some survey data that the administration loves to cite, which generally shows that about 85% of Caltech graduate students either say that they're mostly or completely satisfied with their experiences at Caltech, which as someone on the ground in the labs, didn't seem to be very reflective of the actual lived graduate student experience. And so I was talking about this data with some of my other graduate student friends and some postdocs, and we wanted to see if we could figure out why there was such a big disconnect between the data that the administration is using to inform their decision-making and how we all saw people living and experiencing in the lab situations. Yeah. And so what we, with the assistance and help of the administration, we put together a survey that both asked a lot of these basic how satisfied are you questions, but also really tried to hit at some of the meatier things that we experience. People, whether it's feeling pressure to come to campus to do work despite feeling unhealthy, questions into types of data that are recorded, discrimination, sexual harassment, things like, pretty much running the gamut of what you'd expect maybe to happen
especially in the science, a school that's so science focused, because Caltech is an interesting institute because it's basically only science and engineering, right? Like there's no psychology courses, or I shouldn't say there's no psychology department at Caltech. Even my friends who have neuroscience degrees, they don't really have neuroscience degrees because those are more biology based. They have degrees in chemistry with a neuroscience focus, or like where they're molecular chemists, or they have degrees in computational neurophysiology where they did more neuroscience. So it's definitely a very physics and chemistry heavy school, which of course, as we know, it's not a Caltech issue. It's a it's a science issue that women are underrepresented, that there's a lot of pressures that they experience. So that on top of things about, do I feel like I have to go to school even though I'm sick, or can I take a mental health day because I'm stressed?
And what we tried to look at with this data was not just see, how endemic some of these issues were, but also look at success of different populations of students. We asked people how many publications they'd published, conferences they've attended to, did they speak there, did they present posters, how many hours a week do they work, how much vacation do they take, things like that. So we can also try to hit at some of the fallacies that do exist within some of the departments where, people seem to think that working 80 hours a week is going to make them more productive than working 60. And we have the data to show that it really doesn't.
Yeah.
And so it's been this really, really exciting and really gratifying endeavor to be able to start changing the conversations around campus with the kind of data that we've been collecting. And the administration has been wonderfully great about accepting what we're saying and already starting to spearhead some programs to change it. A thing that was really interesting, though, is I'm a material scientist and physicist by training. I had never taken a statistics course ever, because that was always offered as the lesser option.
Yeah,
between,
of course.
Statistics or calculus. I'm going to take calculus.
Of
Statistics
course,
or complex
especially
analysis.
It's for your field.
Yeah.
It's not necessary. Like when in my undergrad, I should say, it was a little different in my master's, but my undergrad was psychology. And of course, I floated towards the neuro side, but I had the same option. Well, am I going to take calculus, which is interesting, but I'm never going to use as a psychologist, or am I going to really beef up my understanding of statistics? So I love this because you were basically doing psychometrics.
Yeah, and I've been, if you look at at my table in my bedroom, there is a stack of statistics textbooks, and
I got some over there.
I've been teaching myself because we have all this data, and so now the data from bird's eye view of 70% of women report this versus 20% of men report this, but what does that actually mean?
But yeah, do you need to do some ANOVA? Because as we know, the more how, I guess, are you p-hacking by asking too many things?
Yeah,
of course you're going to find some statistical significance when you ask a million different things.
Yeah, and so it's now backtracking and learning the statistics and learning. I'm teaching myself R. That's my new thing. So and oh my gosh, I program in MATLAB mostly, but R is so useful. Holy crap, I can make one command, give me so much. But one really interesting finding from the survey that even without all the statistical analysis, I think it's worth bringing up is we did a lot of demographic breakdowns. We looked at, of the given questions, we'd break it down by graduate student year, by department they were in, by gender, whether or not they were LGBT or underrepresented minorities. And there was one trend that was it was incredible that came out, which was that for every single question where you would want a population to do well, women did worse. For there were zero exception to this. Every single question where you would want there to be less of something, women had more.
Whoa. So something's not going right.
Yeah, no,
right?
and it was
just
interesting to see it
systemically approached.
Yeah, and that was what was so fascinating was it was so systemic. Where if you look at say the LGBTQ population versus people who did not report that they were part of that population, some questions LGBT students did better on.
Yeah.
Some they didn't. There was some shuffling back and forth. But for men versus women, there was none. It was every single question. And so that's part of what's also motivating a lot of my statistics understanding is, okay, how do I describe that? How can I take what seems to be a trend through this data and really make sure that what we're looking at is both real and get a metric for how real it is?
Yeah, you've got to make sure that you have really, really good construct validity, because when you go to present this to professors and use it as impetus to affect change, these very hard-minded kind of physics and chemistry professors are going to be like, did you manipulate this data? I want to know if this is true. And it's no, we ran this all these different ways and we were really stringent. And the truth of the matter is such simple fixes can be utilized here, I would be interested to see how many professors on campus even know the phrase or understand what it means if you ask them, what is stereotype threat?
Oh, I would just love if we could sit down all the professors and have them take an implicit bias test.
Absolutely.
I would love to see the results of that.
And what ends up happening then is you could do the same thing with the students. And we were just talking about this last week on the show with Val, that, because we were talking about kind of some of the struggles, especially in Trump's America, of African American individuals. And, I'm a woman. I'm not Black. Obviously, I am Puerto Rican. I dabbled in the LGBTQ world when I was younger. I actually came out to my mom. I remember going to my gynecologist. I had a girlfriend, and I thought, like, this is it. And I went to my gynecologist, and I was like, I need to stop taking birth control because I'm never going to have sex with a man again. And she was like, we're going to wait a little. It was so sweet. Like, she just got it. I was like, no, it's I'm coming out. But it's like I kind of try to be empathic to certain groups, and then I have true empathy with others, and then I have to kind of figure out my empathy for others because I'm not in that world and I haven't experienced it. And so there are obviously, like you said, the issues that women deal with, or the issues that ethnic minorities deal with, or the issues that, people of different religions, people of different gender identities, all of that. And we think, oh, if you're in that world, that you are inoculated against implicit bias. But the sad thing is, it's so encroaching that, I'm Latina and I have implicit biases against Latina people. And that means then that I have implicit biases against myself. And that's the kind of shit that's so pernicious but it's societally bound, and we have to work on it. And the best way to work on it is A, to become aware of it. The more you're aware of it, the more you can check yourself. And B, for professors to be aware. Of course, if professors understand things like stereotype threat, that if you tell a girl she's not going to do as well, she won't do as well because she starts to worry that she's not going to do as well. And then she underperforms. It's a simple thing that just being aware of, so that they can say things like, I expect everybody to give me the same results on this because you've all been trained at the same level. Something as simple as that, saying before an exam, can actually affect outcomes on an exam. Like, what the fuck?
Yeah, no, I mean, I'm sure you've seen the study about ask the math test, the implicit bias math test. That's crazy.
It's crazy. Yeah, the outcomes are not where. If you're talking about the same study, it was I think high school students who were taking a college level math course, or maybe they were younger, and they did different groups, right? It was like a mixed study design, and they told some of the men, or boys, I should say, that boys tend to do better on this exam than girls. Maybe this is a different test.
I'm thinking about a different.
Oh, good. So we'll talk about both.
Yeah.
So this was a stereotype threat test. They told some of the boys that the boys tend to do better on the test than girls. They told some of the girls, boys tend to do better on this test than girls. So don't worry if it's kind of hard for you. And then they did the same thing with another group of saying, boys and girls always do equally on this test, and same thing with the girls. And they found, and I'm spitballing with the numbers here, but it was something like similar responses across the board to the groups that were told that they do about the same. And it was maybe like a 70% across the board, which is average. And then it's this profound. In the group where they told the girls that girls don't do as well as boys on the exam, random sample of girls should have done just the same. They averaged something like a 19%. It was a profound difference just by priming them that girls aren't generally good at this. It's like that's what stereotype threat is. They were concerned that they weren't going to do as well. Maybe they didn't try as hard because they were already told that they might as well not try as hard. All those things combined, and it was horrible. Okay, tell me about this math study.
So the one that I was thinking of, and again, this is spitballing.
Yeah, we're spitballing the numbers here. So.
But what they did is they looked at a population of Asian girls, and before the math test, they would I think there was a control group. There were 3 groups: control, and then one group where they prime them. They made some reference to their gender before the test, and then one where they reminded them that they were Asian.
Gotcha. Okay.
And, it fell out that I think the group that was reminded that they were Asian did slightly better, and the group that was reminded that they were women did much worse.
Significant.
But it's the same population.
Yeah, and that's not even telling them you're a girl so you might not do well. That's just saying don't forget you have boobs.
Yeah, pretty much.
And then they're like, oh, I'm not good at math. It's so crazy. And I even see it, you see the T-shirts that say I'm too pretty to do math. You see even... There's this company called Blue Q. Maybe I can get this out there. We'll see if they respond to this. And I wear their socks all the time. I'm probably wearing them right now. Oh, no, I'm not. But I'm going to pretend like I am. And they make these amazing socks that say things like motherfucking girl power on them. And, kick this day in its sunshiny ass. And I love them. And they're my mantra socks that I wear every day. And all of them are really empowering. A lot of them are I'm not bossy, I'm the boss. But then there's some that are mornings, no thank you. Or, just things that I love. love. Blame my parent. No, it's my parents' fault. I really like those. But then there's one pair of their whole catalog, and they're all amazing. There's one pair that says the 3 things I hate most in the world are math. And I'm like, why do you put that in with all of these other things that are so empowering and incredible? It like undoes everything. It. And I don't want to boycott the company because everything else about it is so amazing, but I want to kind of make sure that they understand what they're saying and doing by providing that. Like, that is different than the other pair that says, my favorite salad is wine, right? Like, yes. It is very different. And so, and yeah, it's not progressive, it's regressive.
And it's interesting because I've seen this trend at Caltech and where I did my undergrad, at least, where almost every woman in science that I know either has a parent, a grandparent, or a very close relative that's a scientist. Like and that's not surprising that, it's the girls who saw, someone in their close vicinity who made them aware that it's a thing that they could. For me, it was my grandpa made it very aware that this was a thing that I could do too, where it was taken as an assumption that I was able to do this as well. Yeah. But for people who don't have science lineages in their family, it's easy to see how quickly that can be undercut.
That's true. Yeah. I mean, anecdotally, you're right. My mother's an educator. She's a teacher, and my father is an engineer. And I think that inspired. But still, I was that quintessential girl who was like, I'm a creative type. I'm not a scientific type. I'm afraid of math, which is probably why my path to neuroscience was meandering and went through psychology, because I was like, oh, I don't have to take the hard math classes. Oh, I don't have to take the physics classes. I can start with what I think of a, quote, softer science, and then very quickly realized there is a lot of hard science to psychology, and then moved into neurobiology. That way I kind of took a backdoor approach because I didn't feel confident or prepared or like I was good enough, smart enough, whatever, to understand that aspect of hard science.
Which is such a shame, too, because it puts you at now a deficit compared to all the people that like powered through all of those math and science
and
courses.
Now I'm having to kind of teach the same way you're teaching yourself statistics. I'm having to learn these things on my own. And it was never so explicit. That's the thing. It's implicit. It was never like, oh, I'm not good at that because I'm a girl. It was, I'm not good at that because I'm not good at that. I just happen to be a girl. You don't really even make the parallels until much later in life. And you're like, oh, of course I didn't think that because of the things that people are told about how girls operate. But I just thought, I'm not that good at that. Those people are. It just so happens that those people are boys. So yeah, it's a tough thing. And I think it's really cool that I think it's sad that you have to do this in 2017. But I also think it's really cool that you're kind of helping not to break the rose-colored glasses that, some of the administrators are wearing, but helping them to understand that, you actually could have high levels of student satisfaction along with low levels of discomfort in these different areas if you identify that exists, first of all, if you don't pretend it doesn't exist, and then you start doing training and you start doing just it could be just as simple as a colloquium where you remind people that it exists.
Yeah, no, I one thing that I found interesting being at Caltech is, you have professors, and we were talking about this a little bit before, that, faculty members aren't trained in management. So you end up with a huge swath of management styles and techniques, some very healthy, wonderful sets of circumstances, some that are much less healthy.
Yeah, and also not trained in how to teach.
Yes, also
both of those things are lacking because basically you get a PhD and then you start your work tour. It's really just about publishing and grants and, all the things that come along with the science. It's just you happen to also have to manage full labs and teach students.
Oh, seriously. They are asked, so much is asked of them. But so I see people who are in very unhealthy sets of circumstances, but don't realize that the things that they're experiencing are not only not healthy, but also not okay and are against institute policy. And so I'm viewing, and so they'll report that they're happy and satisfied because they're getting what they're expecting, because what they think they expect is, an abusive set of circumstances. And so what we're hoping to do with a lot of this is, both work with the administration, but also use it as an information campaign. The fact that it shows that asking grad students if they're satisfied is not the right question to ask, and address, with people what that word means and what they should be expecting, and what is the data indicates they are not being that they are not getting appropriately, and how they should be more vigilant about that. and recognize the issues that they might have within their personal environment so they can start, at the very least, accept that there might be problems. And if they're open to it, start working towards solutions.
It'd be really interesting for you to potentially partner with a school psychologist or with somebody who
I would love someone who some of the administrators really know what they're talking about and have been helping push us along. But yes, someone who is actually,
or maybe not even a school psychologist, because generally that's more about younger children and some of the issues that they deal with in developmental stages. But they're called IO psychologists. Industrial organizational psychology is actually a field of psychology which is all about work groups and about health in the workplace and interaction between managers and subordinates and things like that. And they probably have some really interesting scales, or maybe just it would be interesting if Caltech were interested in consulting.
I'd love to
based on your data,
that would be awesome.
With somebody who can come in and actually sort of recommend changes based on something that they know works because they've done it in industry. I don't know.
And I say that is one thing that Caltech really respects is expertise. We're all trying to be experts in things and are very good for the most part at recognizing the expertise of others and, putting them to the forefront.
I think that's really cool. And I always think it's cool when something that's great can get even better by limiting hubris and embracing empathy and, trying to say the only way to get better is to remember that I'm not perfect already and what can I learn and what are my mistakes and how can I improve them. So I'm always impressed when we can see something like even a top tier institute want to embrace this and want to do better. So I think that's really cool. And I think it's really cool that you have a heavy hand in that as a student, by the way, who was just like, oh, this is interesting to me. I want to investigate it further. Yay, science.
Yeah, no, seriously. And it is fun because a lot of the science thought process and skills that I've developed, through my undergrad, master's, and now PhD are so applicable to these kinds of questions too.
I love it. All right. So I've kept you for way too long, but I would be remiss if I didn't ask you the last two questions that I ask everybody when I have them on the show. So I can't leave you out. And they're kind of big picture and global and thinky, and I'm so sorry. But I'm super interested to see what you have to say. So they are, when you look to the future, in whatever context matters to you right now, whether it's your own personal future, whether it's the future of your institute or the future of the globe as a whole, number one, sort of what is the thing, if you could pick one thing, that is really disconcerting, that keeps you up at night, that you're most worried about? And on the flip side, just so it's not super depressing, what is the thing that you're really hopeful and optimistic and looking forward to?
So I guess start with the depressing one. I would say the thing that, I am really concerned about is, there are two.
That's okay. You can give me two. No hard and fast rules here.
Yeah, so I guess I'll go with the one that came into my mind second first, which is the state of our global climate and the environment that we are so reliant on, that we have minimal ability to control if things continue to spiral in the way it looks like they're going to, coupled with
most popular answer, by the way.
Oh, I know, which is why I'm saying it first. I'm going to give the second one, my initial instinct second, which will hopefully differentiate me a little bit from the masses.
But there's a reason it's the most.
Exactly. I mean, we look at this incredibly complex climate system that we rely on so much, whether it's, the precipitation systems that we know so well in Southern California, looking at ocean level rise and the populations that will be displaced, looking at disease propagation, crop yields. I mean, there are a lot of intermingling issues that all come out of this one big thing that we already know we aren't taking as proactive an approach on as we should.
Yeah.
And I think that is something that's really troubling to see as a person who works so closely with the people who collect a lot of the data that is continuing to indicate that we are pushing the climate in a direction that we should not.
Yeah. Unequivocally.
Yes.
Yeah.
And so that is response number one. So the other thing that I find concerning is,
so this is the thing that struck you first.
Yes. The one that struck me first is, I think where a lot of these issues come from, which is, I think that the lack of access to good science education from a young age is a huge problem. The fact that if I were to walk down the street in Los Angeles and ask people what they think science is, they would almost certainly tell me that science is the body of facts that tell us things about the world, and that's wrong.
Yeah.
Science is not a dogma. It's a methodology for inquiry that can be applied anywhere. And good science education not only teaches you how to do that critical thinking, but it also makes you appreciate the world that we're in, the one that we're asking all these questions about, in a way where, from what I've seen, people who are, more studied in science, or at least in that thought process, are less inclined to abuse the environment and more inclined to maybe not trust with blindly, but at least look deeply and deeply consider the things and facts and theories that science is putting forward.
And that's an answer that you would get in a progressive city, in a progressive country that is developed, that is, we got our issues right now, but that for the most part is democratic. And I mean, imagine if you did the same survey, and that's in America, you get those answers. Imagine if you did the same survey in Saudi Arabia, in places where 50% of the population isn't really even educated. Like, it just gets worse from there.
Yeah, and so it's, to me, it's really disheartening that we have this, we don't put enough funding, in my opinion, into it, but we have this education system that we're putting so much funding to that still isn't equipped to generate a population that I think is really capable of being able to think critically about the problems in their world around them, so they can actually move towards reasonable solutions.
Absolutely not.
And I find that, especially in light of our current set of political situation, it's really disconcerting. And I also think it's really unfair, because there is absolutely a stratification of our educational system that exists, where, I grew up in an area where I was really fortunate to be able to have, in the United States, to have access to, teachers that had the resources to be able to push me into this type of thought.
Yeah, that's true. And when you're struggling in the inner city and you're just trying to get through the day, and you're just trying to get the kids basically off the street and to focus for, however many hours, and you can't give a lot of individual attention because your classrooms are too big and because there's not enough training. I mean, it's horrible. And so that's why I'm especially worried about the potential Secretary of Education pick that right now, we're recording this on Thursday, February 2nd. It won't go up until Monday. So I don't know, things might have changed by then, but right now she's on the precipice. It's just one vote away, right? And like, this is a woman who has made it pretty clear that she wants to bring intelligent design back into the classroom. Like, these are things that we should be really, really concerned about and fighting back against. So I love that is the answer that you came, because it's especially, I guess, relevant right now. But there's got to be some good news out there. So what are you looking forward to? What are you hopeful about?
I think I like what I generally do, and it's maybe not even a hope for the future. It's like a happiness about the now. Like, I remind myself so frequently, as I'm sitting, speaking into this microphone, in Los Angeles, how far that we have come as humanity. And thinking of, like, what I often remind myself of is how I think soon in the future we are going to look at the fact that we drive cars. We drive these carbon dioxide spitting balls of explosion that move faster than human reaction times can handle, that, cause, a lot of fatalities and a lot of issues. We operate these things without even thinking about it.
Yep.
And I would not be surprised if 50 years down the line, people are going to look back at us and be like, Grandma, you drove that?
Yeah, like, that was so savage.
Yeah. Like, in the way that I look at, like, bloodletting as like a medicinal technique in medieval times, I think that, the rate of development of a lot of our technologies towards making them safer, towards increasing access to them, the developments we're seeing in medicine, I think that the thought that in my lifetime, I can look back at my 20s and think, oh, wow, we were so, thank God we've moved past that in terms of our, like, technological achievements. I think there's never been a point in human history where you can look at your own lifetime and be like, I grew up in a time that I think of as primitive now. And that we have that is a real possibility that we have. And of course, I want to, couch this in the fact that, I understand that this is coming from a place of having the economic access to a lot of these things. But knowing that when humanity works together, and really that's what science is it's a global endeavor of minds racing towards progressively better developments. When we all work together like this, we do incredible stuff. And I find that really hopeful, despite all the conflict we see around us, that there is a huge body of people that are just trying to make the world better.
I love it. That's such a good note to end the episode on. Dagny, this was so much fun. Before you go, I want to ask, not to put you on the spot, but are you active on social media? Are there places like, or do you, I don't know if you have a blog or anything, but are there places where people can be like, hey, I heard the show?
I don't actually. I'm one of the most disconnected millennials. I mean, I have an Instagram account, but it's really just like me going on hikes with my fiance and being like, holy crap, the world is beautiful, which people are welcome to try. I'm really easy to find. People are welcome to try to ferret it out if you want to like stalk me. But other than that, I really just I'm pretty disconnected.
I've had a couple guests on the show who, because I end the description in the show notes with like follow and then @ for their Twitter handle. And so there's been a handful of people I have to leave that off. Totally fine. But just in case, I wanted to make sure. Dagny, this was so much fun. Thank you so much for joining me.
Yeah, no, this is wonderful. Thanks for having me.
Of course. And everybody listening, thank you for coming back week after week. I'm really looking forward to the next time we all get together to talk nerdy.